Okay, so this is the second part of this lecture for this problem. And as I mentioned earlier, what we need to solve is simply for the members DF, DE, and then CE. And for this approach, the most easiest member to solve here is member DF, because we already know regarding the free body diagram that we have here a reaction force. No? We have here R sub F, and then we have R sub A at this point. Now, upon doing that, let's try to solve first for member DF, because this is the easiest. And upon solving for member DF, we need to solve or somewhat represent member DF through its corresponding free body diagram. So by applying either the method of sections or the method of joints. So let's try to apply the method of joints here at member F, because it is somewhat connected to the support roller here at point F. So let's draw the free body diagram. So if this is the point F, this is point F, and then we have here member DF going at this direction. Initially, let's assume that is in tension P sub DF. In tension, that's just our initial assumption. We don't know if it's right or wrong, but if we somewhat solve for member DF, then we will somewhat correct the direction of this member, whether it's compression or tension. Now let's go with this one. This is member FE. So this is P sub FE. And don't forget the slope of member DF, because this has measurement. No? If we go back here in our free body diagram, the height is about 6 feet, and then the length is about 8 feet. So getting the lowest term of this 6 and 8, that should be 3/4. No? This one is 3, this one is 4. Then applying the Pythagorean theorem, the hypotenuse is equivalent to 5. This is at point F. We are applying the method of joints at this portion. So let's try to solve for member DF. We have here the reaction R sub F that is somewhat equivalent to, balikan po natin doon, 20 kilopounds. Okay, this is 20 kips, kaya 20,000 pounds. So applying the laws of equilibrium, summation of forces going upward is positive along the y-axis. So that should be 20 kips, 20,000 pounds. Initial assumption is tension. Okay, so let's get the y member of P sub DF. So going upward, the y component, P sub DF multiplied by its slope, because it is acting upward. P sub DF is the resultant. Okay, then we have here the y component for PDF, and then the x component for P sub DF. So the only thing we need here is simply the y component. So the slope is simply 3/5, because the y component has an angle of 3/5. 3/5. Then simplifying by transposing 20 kilopounds to the other side. So P sub DF is equals to negative 20 kips divided by the reciprocal of 3/5, that is simply 3/5 or 5/3. If you want to get the reciprocal of the slope, 3/5. So simplifying this one, that should be P sub DF. So that would be negative, for this case, is 33.333 kips. Goes like that. So negative, our initial assumption is in tension. No? So means to say, if we have a negative value, it means to say that our initial assumption is wrong. So this should be in compression. So let's correct the direction of that member. So P sub DF is equals to positive 33.333 kips in compression. So this should be the force acting here at member DF. Okay. it's equivalent to 33.333 kilopounds or 33,333 pounds in compression. Okay, so bear in mind with that one. So what would be the next easiest member to solve for this problem? So let's go back here in our free body diagram. So we already managed to solve for member DF. And let's try to solve for member CE. No? If we are going to solve for member CE, we need to use the method of sections. If we want to use the method of sections, we must cut the whole structural truss by approximately 3 members only. Because if we somewhat cut 4 members, that would exceed the available formulas in order to solve a determinate problem. So we are going to cut somewhere here at this portion. So this is section A. This is section A. Then we're going to use the left side of this section. Okay. Let's try to draw that here on the whiteboard. Just going to erase this one so that we have additional space to solve. Okay. So upon doing that, we just need to draw again the free body diagram. So this one is point A. We have here R sub A. R sub A. This is point A. We have here a member going at this direction. Oh, sorry. Going straight only. Like this. And then at this point, this is B. Then this is the cut member going at this direction. Just going to extend, no? We are using the left side. Okay, we are using the left side. And at this portion also, going like this. See, we're using the left side of the whole structure. This is the free body diagram. This is point D, this is point C, and then this is point E. Okay, so let's continue. This has a length of 8 feet, and then this one also has a length of 8 feet, and this one has a length of 6 feet. And what we need to do is to solve for member CE. Okay, we're going to solve for member CE. So we have here 30. We just need to exclude the 30 kilopounds because we are using the left side. Okay, because there are a lot of students that somewhat get confused why I didn't include the 30 kilopounds here at section E. And the reason for that one is because we are using the left side of the whole truss structure. And now, from this point on, we have here R sub A equivalent to, according to what we solved earlier, that would be equal to 10 kilopounds. This should be 10 kips, so I will just retain the unit, but it is understood that this is in kilopounds. So let's try to solve for member CE. Don't forget that it also has a slope. This one is 3, and then this one is 4, and then this one is 5. And then the question here is, how did I get that? Then the length of member CE along the x-axis is 8 feet. And then its height is equivalent to 6 feet. Then just get the lowest term between 6 and 8. That should be 3 and 4. And then use the Pythagorean theorem. 3 squared plus 4 squared, that is 25. Square root of 25 is equals to 5. That's why we have 3, 4, and then 5 for the slope. Solving for member CE. Let's use the method, or rather the principles of summating all of the moments for this section. Okay. So the question here is, where should be the perfect point where we apply the summation of moments? And for this point on, we need to find a certain point that would eliminate most of the unknowns. And then after getting that pivot point, then we can just simply solve for member CE. Okay. So again, for this case, we are using the left side, and then that pivot point should be at point B. So if you are wondering why we need to use the pivot point here at B, because if we use the method of summating all of the forces at this point, we can eliminate member BD, member BE. Now we can eliminate two members. So that would be easier for us, because if we use the summation of moments here at member point E, we somewhat eliminate member CE, which is very inconvenient for us. And then if we somewhat use the pivot point here at point D, then we would have three unknowns: the x and y component of CE, and then we have here BE, which is we don't know the value. Okay, so that's why we somewhat use the pivot point here at point B, so that we can eliminate BD and BE. And the only remaining force that would rotate is member CE and this RA. Okay, so let's try to summate all of the moments here at point B. So summation of moments, positive going clockwise at point B is equals to 0. Then that should be P sub CE. Okay. Where is the rotation for this member? We are assuming that it is in tension. So it's rotating counterclockwise, P sub CE. Don't forget the slope. So what is the component that it tends to rotate member CE? That should be the X component, right? Because the Y component is directly acting here at the pivot point, point B. So that's why we need to use the X component only. So that X component is 4 over 5, the slope. 4 over 5 multiplied by the moment arm, or rather the perpendicular distance, equivalent to 6 feet. So 6 feet. And what would be the other force that would tend to rotate the structure? That is R sub A. So the rotation is positive because it is rotating clockwise. So plus 10 kips multiplied by the perpendicular distance of 8 feet. Then isolating P sub CE, P sub CE multiplied by 4 over 5, and then the moment arm 6 feet is equals to, that is approximately 80 kips foot. Then dividing both sides by this one, 4 over 5, and then 6 feet. So 4 over 5, then 6 feet. So cancel and then cancel. P sub CE is somewhat equivalent to, if you are going to simplify everything, that should be 16.667 kips. And then since we have a positive answer for P sub CE, because our initial assumption is in tension, and then we have a positive answer, that would mean that our initial assumption is correct. So we managed to solve for P sub CE. Then let's continue with part 3 for this sample.